There's lots of different ways we can blend colors with shading, and the way we're going to talk about it is based on the HSV color model. So the HSV color model has hue around the edge of the top circle here, varying in along the color circle, and then the value is going to vary from white at the top in the center of the color circle to black at the bottom tip of this cone. And then the saturation of the color, or the richness of the color, is going to increase from white to the pure hue as we move from the center of the model out towards the edges of the model. What we're going to see is that we're going to set the colors on this map on this top surface of this HSV color model here. So we're going to be picking pure hues and pure and with some amount of saturation as the color on the map. And then we're going to let value vary across the map based on things like hill shading. So here's a hill shaded map of a portion of the Grand Canyon. And as we can see, it has a very three-dimensional effect, and we're able to see where the highs and the lows are. And in doing all of that, we're only using the value of the HSV color model. Now we can add hue and saturation as colors, and in this case it's going to be based on the geology, the different geologic layers of the Grand Canyon, and now we're able to see that all together. On every pixel in this digital elevation model, the hue and saturation are based on the type of geology, and the value is based on the hill shading, and we're combining these. We can do this in various ways, such as partial transparency, so that we're seeing those three components of the HSV color model together. We could do a similar thing with this type of population density map if instead of using hill shades, we pretend like this is a 3D model of the land with the places with higher population density higher, and then we shine light on it so it casts shadows and creates soft shadows wherever the things are highest. So this is population density, and all of those various values of population density going from low population density in white to highest population density in dark red are just varying the hue and saturation of those colors of yellow and orange and red. Here we just take off the boundaries so that all we have are the colors without any boundaries to represent the counties. And now we can take this black and white model, which is basically just the shadows that would be cast if these things were actually lifted up into 3 dimensions to represent what the population density was. And now, and once again, this is only using the value axis of the HSV color model. So on top of that, we can add the hue and saturation from the previous map, and we get a map that looks like this. So now we've combined hue and saturation based on the color of orange to red, and the value based on the shading, which is basically the cast shadows of these higher areas. And we're able to combine those all in GIS in order to make a map that really has a nice three-dimensional effect and hopefully points out to people exactly where the highest and lowest areas are. One interesting thing about this this sort of approach is that we actually kind of blur or even get rid of boundaries that aren't very important. If population is similar in 2 neighboring counties, then one is not higher than the other, and it's not going to cast any shadows. So this area around Atlanta, we can see the population density around Atlanta, but as we move, especially towards the southeast away from Atlanta, there are counties there that are indistinguishable because one is not casting a shadow on the other. And if we were just interested in where the population was changing, that could be a very useful thing.